Hello everyone, welcome to my YouTube channel. Myself Sandhya, I am from SVC. Before getting to the topic, I request everyone to like, share and subscribe my channel. In today's session, we are going to discuss about the 2D pipeline. The learning objectives of the 2D pipeline, the clipping window, normalization and the viewport transportation. First, let's have a look on the 2D viewing pipeline. Procedures for displaying views for the two-dimensional pictures on the output device. Those are specify which parts of the object to display, that is clipping window or the world window or viewing window, and where on the screen to display these parts. On the viewport and the clipping window is the selected section of the scene that is displayed on the display window. Viewport is the window where the object is viewed on the output device. And this is the 2D view, and this is the diagram of the 2D viewing pipeline. So 2D viewing pipeline, which construct the world coordinator scene using the modeling coordinating transformation, convert world coordinates to viewing coordinates and transform viewing coordinates to normalized coordinates, like example between 0 and 1 or between -1 and 1, and map normalized coordinates to device coordinates. The clipping window is the most often a rectangular window, and the clipping window can be seen as a viewing window. Coordinate system is set up to the world coordinate frame, and graphic system provides function to define a rectangular clipping window in the world coordinates, and this is the clipping window. So next, the normalization and the viewport transformation. There are the two main approaches to the 2D viewing. The main two approaches of the 2D viewing is normalization and viewport transformation, and mapping the clipping window into normalized viewport, which involves scaling and clipping window to the size of the viewport, then translating the original of the clipping window to that viewport. And this is a normalization and viewport transformation diagram where a point x, w and yw in the world coordinates clipping window is mapped to the viewport coordinates of the xv and yv within a unit square, so that the relative positions of the 2 points in their respective triangles are the same. So you can see the diagram of the normalization and the viewport. This is the clipping window and another side is normalization viewport. The normalization and viewport transformation, okay, where the clipping window is to normalization square and the to screen viewport. A point of the xw and yw in the clipping window is mapped to a normalized coordinate position of the x normal and y normal, then to the screen coordinate position of xv and yv in a viewport. So objectives are clipped against the normalization square before the transformation to viewport coordinates. Next, we discuss about the 3D viewing. With a three-dimensional viewing, these are the steps for computer generation of a view of the 3D dimensional scene are somewhat analogous to the process involved in taking photograph. So you can see which we can view in the 3D. And the camera analogy is viewing position, camera orientation, size of the clipping window, where in the camera, see, as you can see, it's taking a process involved in a photography. With the photography as a camera analogy with its viewing position and size of the clipping window and camera orientation of the picture to view in the 3D. And the viewing pipeline is the general processing steps for modeling and converting a world coordinate description of the scene into device coordinates. So these are the coordinates of modeling transformation, viewing transformation, projection transformation, normalization transformation and clipping, viewport transformation. Um, like first is the modeling transformation, the general process which converts the steps from modeling to converting a world coordinates, where WC is world coordinate and MC is modeling convert the description of the scene. And the second is the world coordinate position are converting to viewing coordinates. like world coordinates, which converts to viewing coordinates, and that viewing coordinates converts the viewing coordinates description of the scene of the coordinate position of the projection line, and the position of the projection plane will then map it to the normalization coordinate and output devices. And the weaving coordinates of the weaving coordinate system describe 3D object with respect to a weaver. A weaver or a projector plane is to set perpendicular to ZV and align with the XV and YV. With specifying the weaving coordinate system, which is we first pick a world coordinate position and call weave reference point. Origin of our weaving coordinate system, where P0 or P0 is a point where the camera is located, and the weave reference point is often chosen to be close to or not surface of the some object or at the center of the group objects. So you can see like this is how the view reference point as specifying the viewing coordinate system as designed. Thank you. Please do like, share and subscribe my channel. Once again, thank you.